in this table, I've tried to put together the couple of formulas that you will need to be aware of. And so you can see that if you're calculating average velocity, then you must use the formula change in displacement over time. If you want to calculate average speed, you want the total distance travelled divided by time. And I've talked about the difference between displacement and distance. And we won't come to these two until exercise 5A and 5B, 5B and 5C, because you can see here that those formulas involve calculus. So for instantaneous velocity, you use you're going to differentiate displacement with respect to time, and the only change for instantaneous speed is to take the absolute value. But there'll be a whole lot more on that for the next two exercises. But for now, we're going to focus on displacement, distance, time, velocity, speed, average. So let's have a look at this example. A particle is fired vertically and moves according to the equation x, and remember x is the displacement, is equal to 4t minus t squared, where displacement is measured in metres and the time t is measured in seconds. So what it's asking you to do in part A is to complete the table for this particle. So let's do that now. Remember, the values we're putting in here are the displacement of this particle at these various times. I'll just pause the video and fill that out. So you can see that all I've done is I've substituted t equals 0, and I got 0, t is 1 and 3, t is 2, but 4. When t was 3, I came back to 3, and when t was 4, I came back to 0. Let's see if we can get a bit of an understanding of what's going on here. So it says a particle is fired vertically, so that means its particle is fired straight up. It moves according to this equation, so we can see that it was at 0. So 0, the reference point, 0, is where the particle was fired from. That may not always be the case. I guess if we thought about the situation where somebody was standing on the ground and let's say they were able to fire from the ground, so the particle was fired from here straight up, then yes, we're calling the ground 0. And it would, as we know, a particle will go up and then it will fall back down, which is what our displacement values are indicating. However, if this person was standing on a cliff, so they're standing here now, they're standing here, and let's say they're fired from the edge of the cliff, the particle will go up, and yes, it will come down, but in this case, you could see it would make sense that if the top of the cliff is called 0, then we'll have some negative values, and so we might talk about a negative displacement. Could be the same as if the particle was fired from in the water. You could go, when it returns down, it goes under the water, and you could get negative values. I guess if a particle is fired from here, the top of the cliff again, it's fired from here, but this is 0, the ground is 0, then we wouldn't get this situation. At time 0, the displacement would be a value other than 0. So just be aware of those different situations. let's look at part B. Hence find the average velocity. What do we know about average velocity? Average velocity is equal to the change in displacement. So at t is equal to 0, the displacement's 0. When t was 2, the displacement's 4. So we can see the change is from 0 to 4, which is 4. And the time is 2. So average velocity is 2 meters per second. From 2 to 4, so average velocity. So at 2, we're 4 units, and then at 4, we're 0. So we've gone from 4 to 0, which is -4, because we called up positive. So it's -4, and the time is 2. And so we've got -2 meters per second. And from 0 to 4, the average velocity, it's gone from 0 to 0, which is 0, divided by 4 is still 0 meters per second. So in part C, they ask you to sketch the displacement time graph. So the displacement time function, displacement time function is actually x is equal to, displacement is equal to 4t minus t squared. Now, without the table of values, let's just have a think about that. We can see that that is a quadratic. It's an upside down parabola. So we know that from its equation, and we can also see, since I've now sketched x with respect to t, that you do get this nice upside down parabolic shape. Now, it also asks you to add the chords corresponding to the average velocities calculated in B. So the reason that they're wanting the chord is because if we think about in B part 1, we were getting the average velocity, we were getting the change in velocity at time 2. So we wanted the velocity at time 2 minus the velocity at time 0. That was the change in velocity at time 2 minus the velocity at time 0, and over the difference in the time, so it's 2 minus 0. Now, that's just our gradient formula. It's just the gradient of the chord. It's the rise, which is the change in displacement over the change in time, rise over run. In part 2, the same situation. We had from time 4, which is here, minus time 2, which is here. So we had 0 minus 4, hence the minus 4. And again, we can see that the average velocity is equal to the gradient of this chord. You look at the green chord in this case, it's got a negative slope. We had a negative gradient. So really all part C is doing is showing you the connection between average velocity and a chord. Average velocity and a chord. And it's just the gradient of the chord. And 3 is the same in that the chord over this time span from 0 to 4 is a horizontal line. And the gradient of the horizontal line is 0. Its rise is 0. Doesn't matter what the run is. Its rise is 0. Hence, it satisfies, it's the gradient of the chord, and in this case it was 0. And then in part B, it's asking for the total distance. I guess we don't have an equation for the distance, so we've got to rely on our understanding of what has happened. But put yourself back in the position of what's going on here. A particle has been fired vertically in the air. So imagine you're throwing a ball. Vertically, you throw it up, it goes up a certain height and it comes down. How far does it travel? It travels up to its maximum height and back down to the ground. So what was the maximum height that this particle traveled? It went up 4, then came down 4. Its total distance it travelled is 8 metres. Therefore, the average speed is, what do we write in the table? Average speed is the total distance divided by the time. So it's 8 divided by 4 seconds, which is 2 metres per second, is its average speed. Average velocity 0, average speed 2. Now, you can see there's a clear difference in the values, there's a clear difference in the concept. Please make sure you've made all necessary notes about the differences and try and no, I've got another example for you. I'll do it in a different separate video.